Hey guys, today we are looking at our notes for 2.3, which is all about something that I like to call fraction busting. In an equation, when we're dealing with an equation that involves fractions, depending on how many there are and where they're located, it can really complicate things. Now, if we wanted to, we could still solve our equations the old-fashioned way, like we did in the first two sections of this chapter so far, where we're doing our inverse operations to isolate our variable and then get rid of whatever coefficient is attached to that same variable. So in box one, let's just pretend we don't know what fraction busting is, because I haven't told you about that yet. But if we're going to solve this the old-fashioned way, meaning we're just using our inverse operations to try and isolate our variable, we've got 5/6 x minus 3 over 4 equals 1/3. So inverse operation wise, we would start by adding 3 over 4 on both sides because it's a subtraction of 3 over 4. So we're going to add the opposite, right? Do the opposite inverse operation. That gives us 5 over 6x equals, well, 1/3 plus 1/4. We looked at it last chapter with adding two fractions together. We have to find a common denominator. Easiest one would be 12. If I multiply this first one times 4 and the second one times 3, they'd both be twelfths. So that would be 4 twelfths plus 9 twelfths, which gives me 5/6 x equals 13 over 12. From here, we've got our variable isolated, right? We've got the variable by itself. There's nothing else along with it on that same side. So what I have to do now would be get rid of that coefficient. We could technically divide by 5/6 on both sides, but we know that when we're dividing a fraction, it's really multiplying by the reciprocal. So that's just the step that I do right away. It just saves us some time and headache of remembering that we have to flip to multiply, because 6 over 5, if I multiply by that on both sides, my 6's and my 5's cancel out. I'm just left with x. And then over here on the right side, depending on your personal preference, you could multiply straight across first and then reduce. I like reducing right away. It makes it more obvious, at least to me. If you don't like it, then multiply across first, whatever floats your boat. But after I reduce my 6 and my 12 here, I'm left with just 13 up top and then 10 in the bottom, and that is my solution. Now, that's not horrible, but especially the fact that we need to find a common denominator, it makes it more difficult, especially with the fact that we have fractions in 3 different places. It would be awesome if we could just get rid of our fractions in one fell swoop and then go back to what we would consider probably a normal problem for equation solving, at least. So in order to kind of combat those fractions, to get rid of those fractions, we have this other option I call fraction busting. I think the textbook calls it clearing fractions. I like fraction busting better because it sounds more awesome. But the way that we'll do this to fraction bust, instead of having to deal with finding common denominators at each different stage or each different step in my problem, I look at my problem as a whole and look at all the denominators that happen in that equation. Whatever that common denominator is, whatever that LCD, that least common denominator is, of all of your denominators in your fraction, multiply your whole equation by that number, by that LCD. So the one that I started with here, 5 over 6x minus 3 over 4 equals 1 over 3. The LCD, the least common denominator of all 3 of those numbers, of 6, 4, and 3, the smallest number that all 3 of them go into is 12, which is what it says down there. So what I would do, and we're going to do this in box 2, is multiply all of my terms by 12. When I do that, all of my fractions reduce, and I no longer have to deal with fractions anymore in my problem, which is awesome. So if we jump in here to box number 2, we've got the exact same equation, but let's do this using fraction busting. So I'm going to use yellow for my fraction busting multiplication. So in number 1, we already talked about 12 is the LCD of 6, 4, and 3. So if I multiply everything in my equation times 12 here, times 12 there, times 12 there. What happens as I start to simplify, right, my 12 and my 6 reduce, this is left with just a 2. my 4 and my 12 reduce to a 3, and then my 3 and my 12 reduce to a 4. So you can see all three of my fractions, the denominators, got canceled out. So I don't have a fraction anymore. What I now have to do is just simplify each of those individual terms. 2 times 5x should be a 10x, still minus. 3 times 3 is 9. 1 times 4 is 4. And that's a whole lot easier of a problem to deal with. 10x minus 9 equals 4. I can do that in my sleep. Right? Add 9 on both sides. 10x equals 13. I divide by 10 on both sides. And holy moly, I still get 13/10. So you do still have to deal with finding a common denominator, but you have to do it once, and then you're done with fractions for the entire rest of the problem, which is just awesome. So let's do another one here for number 2. Number 2, we've got 2 over 5x plus 1 over 2 equals negative 7 over 10. So looking at my LCD of all three of these terms, the smallest number that all three of them go into is 10, right? Because 5 times 2 is 10, 2 times 5 is 10, and then 10 obviously is already 10. So if we do that, again, I'm going to use yellow, multiply by 10 all the way through, and then start looking at how things simplify. Whoops, 5 and 10 reduce down to a 2, 2 and 10 reduce down to a 5, and then my 10s totally cancel. So here, my first term, I'm left with 4x. 1 times 5 is 5, and then negative 7 over here all by itself because the 10's canceled out. So once again, nice easy problem. I can solve from here. Minus 5 on both sides. 4x equals negative 12. That's a weird looking 12. Divide by 4 on both sides, and I get negative 3. Negative 3. So that's the general process of fraction busting. Now, obviously there are more challenging examples of that, and we're going to take a look at those in box number 3. So in box 3, a little bit different of a format because we've got an expression being multiplied by a fraction, but my process is still the same. You just need to be careful of what we consider a term to be. Because in this problem, there are 3 terms in my equation. I have my first 1/5 times x plus 1. That's my first term. I have my 1/4 times x plus 3. And then my 2. That's all by itself over on the other side. So I only have 2 denominators in this problem, 2 fractions. So 5 and 4, the least common denominator, the LCD between those two would just be 20, is the smallest number that both of them go into. So I'm going to multiply all 3 of my terms times 20, all the way through my equation. So 20 and 5 reduced to a 4. 20 and 4 reduced to a 5. And then on the right side, because I didn't have a fraction on that far side of my equation, it doesn't reduce anything, so it's just going to be 40 once I collect my like terms. So when I rewrite this, 4 times x plus 1, 5 times x plus 3 equals 40. So from here, even though it's a complicated one, I still am just a regular, like an Algebra 1 level solving problem. I'm going to go ahead and distribute my 4 into that parenthesis, my 5 into that parenthesis. So I've got 4x plus 4 plus 5x plus 15 equals 40. I'll collect up my like terms. We've got 9x plus 19 equals 40. So minus 19 on both sides. That gives me 9x equals 21. Divide by 9 on both sides. Depending on how you want to leave this, I would put this as 7 over 3, just reducing 21 and 9 by 3, or by 3. Okay. Another form of that, very similar, another form of that same type of equation is number 4 here. We're dealing with x plus 1 over 4 plus x plus 2 over 6 equals 1. So now, again, LCD by least common denominator would be 12. 12 is the smallest number that both of them go into. If you don't recognize that and you use a number that's bigger, like if you just use 24 because you looked at and just saw, oh, 4 times 6 is 24, I know that's a common denominator, that's totally fine too. You should still get the same solution at the end. But I'm going to use the least common denominator just because it's going to keep my numbers as small as possible. Oops, times 12. So here again, 12 and 4 reduced to a 3. 6 and 12 reduced to a 2. Now be careful here because I'm multiplying my entire fraction by 3 and by 4, or sorry, by 2. So this is still set up similarly as that last one, where we have our quantity that's multiplied by our number. So I'm still going to be distributing in here. That gives me 3x plus 3 plus 2x plus 4 equals 12. Collect up my like terms. 5x plus 7 equals 12. So when I subtract 7 on both sides, I get 5x equals 5. So of course, divide by 5 on both sides, and we get positive 1. Positive 1. All right, box 4. So box 4, I'm going to show you this because the textbook discusses it. I don't think it's super necessary because you guys are allowed to use your calculators, so it shouldn't be a big deal. But if you want to, you can do this. Kind of not really fraction busting, but decimal busting, I guess. I don't really use that often. But if you get thrown off by having decimals in your equation, if you don't like those, you can. There is a method to get rid of your decimal places and be dealing with just nice whole numbers again. So to do this, we're going to be multiplying by some power of 10, meaning like 10, 100, 1,000, 10,000, 100,000. However many decimal places show up in your equation, if you wanted to get rid of them all, you would just have to multiply all of your terms by a power of 10 that has the same number of zeros as decimal places that you're trying to get rid of. So like for number 5, all 3 of my terms here that have a decimal place are just a single decimal place. So 1.2, 3.5, 2.1. If I'm trying to get rid of that one decimal place, I would have to multiply, in this case, since I have one decimal place I'm trying to get rid of, I just multiply by 10, because 10 has 1 0. So if I did that, I'm going to multiply times 10, times 10, times 10, times 10. Now again, even though my x doesn't have a decimal place that I'm trying to get rid of, I have to multiply everything in my equation times 10. So when I do that, it gives me 12x plus 35 equals 21 plus 10x. So multiplying by 10 just moved my decimal place over one space. So 2.1 becomes 12, so on and so forth. You can see what I was doing there. So from here, it's just a regular equation solving process. I get my x's together on one side, get my numbers together on the other. I'll cancel out there and there. That gives me 2x equals 14. So when I divide by 2 on both sides, I get positive 7. But of course, you don't have to do that. Like I said, I'm not one who usually does that because we have our calculators and most of us are probably double checking these numbers even as whole numbers, let alone as decimal places. So whether you use this process or not, that's up to you. I definitely would use it when you're dealing with a bunch of fractions. It's a great resource to use, a great tool to use. There's other smaller numbers that you could have multiplied by to get rid of my fractions or my decimals, especially like with number 6 with 0.25 and 0.15. Those ones can be written as simpler fractions. You can always convert between the two of them. But again, if we're just using this general process, if you feel like you have to get rid of your decimal points, I'm trying to get rid of 2 decimal places here. So I'm going to have to multiply by a power of 10 that has 2 zeros. So I'm going to be multiplying 100. So if I do that in all 3 of my terms, times 100, times 100, that just gets rid of my decimal places. I just swing my decimal places 2 spots. All right, so for this first one, 100 times 25, or times 0.25 makes this a 25 times x plus 2 minus 15 times x plus 3 equals 400. So whether or not you think that's easier to solve is up to you. But from here, same process that as we've been doing. Distribute my 25 and my negative 15. So 25x plus 50 minus 15x minus 45 equals 400. I collect up my like terms. That gives me a 10x plus 5 equals 400. Right, because remember, I'm on that side of the equation. I just collect up my like terms since I'm not moving across equations. So minus 5 on both sides. 10x equals 395. So when I divide by 10 on both sides, x equals 39.5. Which you also would have gotten if you just left it as decimal places. Again, it's up to you on whether or not you use these kind of shortcuts, these different skills. I would definitely recommend it when you're dealing with a bunch of fractions. Makes your life a whole lot easier. When it's decimals, it's kind of up to you. I don't use them personally, but feel free to as well. That's all we got for 2.3. So your homework is on the page there, page 122, just 10 through 36, the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.